And now we're going to start Chapter 5, which is nomenclature. So we're going to learn how to start talking like a chemist. Just like you know how to talk English, French, Spanish, and any other language, we're going to now learn how to talk chemistry. So to start, we have what's called binary compounds. Those are composed of two elements, and we can break those binary compounds into two subcategories. So first we have what's called ionic compounds. Those compounds are between a metal and a non-metal. And just remember that our metal elements lie on the left side of the periodic table, and our non-metals are on the right side. Then second, we have the binary covalent. Our covalent is between a non-metal and a non-metal. So it's going to be between two atoms on the right side of the periodic table. Binary ionic compounds, those contain a cation and an anion. We have three types of those. So to start, we have type 1. In type 1, we have ions that are only found in one form. So group 1, right here on the periodic table, is always going to have a +1. Group 2 here is always going to have a +2. So in those elements, you're always going to see sodium, Na, as a +1, or magnesium as a +2. Then we have our type 2 compounds, which they are metals that can be found in with more than one charge. And we'll get to those in a bit. Here's a list of simple cations and anions. And if you remember how we name a cation and anion, the cation is just the element itself plus the word ion. So here for hydrogen, it would just be hydrogen ion, lithium ion, sodium ion, potassium ion. Then for anions, we just add the ending IDE. So hydride, fluoride, chloride, bromide, iodide, oxide, and sulfide. Now we can talk about how we name these compounds. So when we name them, it's always the cation first and then the anion second. And that cation is always just the simple form. So hydrogen is hydrogen, sodium is sodium. Then that anion, we always add the ide. So hydrogen fluoride, or sodium chloride. So here we have aluminum chloride. The aluminum is a 3+, and we use the name aluminum. And the chloride is a 1-, and we use chloride. Notice the IDE ending. But if we look at the charges, so right here, our ionic compound always has a neutral charge. So aluminum is a 3+, and we only have one of those. Chlorine, though, that is a 1-, but because we have 3 of them, we can add that up, +3 and -3, our overall charge is 0. So this here is an example of some ionic compounds. Potassium chloride. Potassium is a +1, chlorine's a -1, so we have a charge of 0. Now magnesium bromide, magnesium is a +2 because it's in group 2, and the bromine's a -1, but since we have 2 of them, it still comes out to 0. Calcium is in group 2 also, so it's a +2, and oxygen is on the right side, and in group 6, it's 2 away from the noble gases. It is a -2, so we have an overall charge of 0 also. So here is a sample problem for you to try. What is the name of the compound SrBr2? Correct answer is D, strontium bromide. Remember, it may be tempting to do dibromide, but because this is an ionic compound, we do not have to use the prefix such as di. We can assume that we have the +2 from strontium and the 2 -1s from bromine will make a neutral compound. Next we have our type 2. These are our ionic, binary ionic, but these are with the different charges. So for example, iron here, it can either be a +2 or a +3. And since this charge can be different, we need to figure out how we can specify that. So instead of using more numbers, because we already have tons of numbers in our formulas, we use a Roman numeral to indicate the charge. So for example, a +2 is going to look like the Roman numeral 2. +3 is going to look like the Roman numeral 3. So here are some common type 2 cations. So here's our iron as a +3 and our iron as a +2. So we have it as iron 3, Roman numeral 3, and iron 2, Roman numeral 2. So we also have copper, cobalt, tin, lead, and mercury. Now here's how to name those type 2 ionic compounds. It's very similar to our type 1 in that here in number 1 it says the cation is named first and the anion second. Exact same as before. But now since that charge can be different, it's not always the same, such as those group 1 and group 2, we need to specify those charges with the nomen numerals in parentheses. So here we have iron 3 oxide, because our iron is a 3+, and our anion is oxygen, so it's oxide. And we can check ourselves, so we have 2 irons with a +3, and we have 3 oxygens with a 2- to get an overall net charge of 0. Same thing, just like in our type 1 ionic compounds, we want to have a net charge of 0. So now we're going to look at how to go between the name for a type 2 to the formula, and from the formula to the name. So let's start with the name. So we're going to start with the iron 3, the name, oxide. So we know our iron, so we're going to write Fe, and we know we have oxygen, so we write FeO. Now our iron is a +3, as it tells us here in the name, but we know our oxygen, just based on looking on the periodic table, it's in group 6, 2 away from noble gas, it is -2. Now if we add 3 and -2, we get a +1. So we do not have a neutral compound here. So we need to figure out how we can manipulate this with whole numbers to get a neutral compound. So if we look, we can multiply iron by 2, so 2 times +3, and we can multiply oxygen by 3, so 3 times -2, and we will get a neutral compound, or 6 minus 6 equals 0. So it would be an iron 2O3. And that's how we go from the name to the formula. Now we can go from the formula, Fe2O3, to the name. Now just looking at a quick second, we don't know what iron is. Iron is a transition element, so it can be either a +2 or a +3. But we do know what oxygen is. And we know that oxygen must be a -2, looking at the periodic table. It's in group 6, 2 away from the noble gases. So we have -2, and it's times 3. So what charge overall does that give us? A -6. Well, we also know that iron, we have 2 of them. We don't know the charge necessarily yet, but we have 2 of them. And we know that we want our compound to be neutral, or 0. So now we can figure out what must our charge be, x, in order to cancel out that -6. So looking, we need a charge of +3. Because +3 times 2 will give us 6, and 6 minus 6 equals 0. So now we know how to go from the name to the formula, and the formula to the name. So here are a couple examples of a type 2 ionic compound. Copper 1 bromide. So here's our bromine. We know it's a -1. So our copper must be a +1 in order to get to 0. Sulfide, S, we know that that is a -2 looking at the periodic table. So our iron must be a +2. Now this lead 4 oxide, we know our oxygen also is a -2, but since we have 2 of them, it is actually a -4. So our lead must be a +4 in order to cancel out that -4 from the oxide. So what is the name of the compound CrO2? the correct answer is C, chromium 4 oxide. Because our oxide, we have 2 times -2, which is a -4. So we must have a positive. We must have a positive 4. Next practice question. What is the correct name of the compound that results from the most stable ion for sulfur and the metal ion that contains 24 electrons? Give a second. Correct answer is D, iron 2 sulfide. Now, we know that it's a sulfur, so I'm just going to say S, but we don't know the metal, so I'm just going to put X. So sulfur, we look at the periodic table, it is a group 6, so we have a -2. So what must our X be in order to have a neutral charge? A +2. So those together equal 0. Now we know that our ion has 24 electrons. So how many electrons does the uncharged have? If it's a +2 and it has 24, so how many must the uncharged metal have? 26 electrons. So we lost 2 electrons to go to 24, and we have a +2 charge. And the only metal with 26 electrons would be iron, with atomic number 26. Now finally, type 3 binary compounds. Now the difference between these type 1, type 2, and now type 3 is that type 3 is going to be between 2 nonmetals. So we're not going to have any metals involved. Now if you remember, our nonmetals are on the right-hand side of the periodic table. Naming these compounds is going to be very similar to type 1 and 2. The first element in the formula is named first, and the full element name is used. So let's say like a type 1, sodium chloride. The full name of sodium is used. Then the second, though, just like in the type 1, we use the anion, which is just the ending "ide." Now, the prefixes, we need to use a prefix in order to denote how many of that element we have. Mono is never used for the first one, so we don't say monocarbon dioxide. Because there's just one, just by using the word carbon, there is just one. So this is a list of prefixes that you need to know. So we have mono, di, tri, tetra, penta, hexa, hepta, and octa. So all these will indicate how many of that specific element are in the compound. So these are 3 examples here. We have carbon dioxide, CO2. Notice the use of di to indicate our 2 oxygens. Sulfur hexafluoride, our hexa for the 6, and then we have dinitrogen tetraoxide, so our 2 nitrogen and 4 oxygen. We do not, though, have to say monocarbon dioxide, because just by saying carbon, that indicates only 1. Now some practice. What is the name of the compound SeO2? Correct answer is B, selenium dioxide. We have to indicate with di the number of oxygens. It would not be selenium 4 dioxide, even though oxygen is a -2, and since we have 2 of them, it's a -4 total, so the other compound we think would be +4, but if we look and find selenium, it is not a metal. It is not a metal. And this right here is a good flow chart for you to be familiar with to help you determine how to name a compound. So the first thing you need to do is ask yourself, is this a binary compound? Are there just 2 elements? If yes, then we look, is there a metal present? Are there any elements that are on the left-hand side of the periodic table present in our compound? If there's not, then we use a type 3, because that means it's 2 nonmetals, so we need to use our prefixes. If there is a metal present, then we need to ask ourselves, can that metal have more than 1 charge? Or, another way to ask that is this a transition element? Does this lie in the middle of the periodic table? If it does, then we can have multiple charges. If it does not, then it's a type 1, and we just use the cation and then anion.